Hello, this is Looking Forward for Physics 100 for Friday, the 19th of February, 2016. As you get ready for class on Friday, I'd like you to read pages 128 to 132 and 142 to 150 of the Hewitt book. And I'd like you to think about the following couple of questions. The first one has to do with circular motion. Imagine that I was going around in a circle, or I had an object, actually, that was going around in a circle around something. Now, we know from class that that object has an acceleration, and that acceleration is given by v squared over r toward the center of the circle. We know also from class that the force is the mass times an acceleration. And so my questions are, if I have an object going around in a circle that has an acceleration, is there a force required? If it's a bucket of water with a rope, what is providing the force on the bucket of water? And what happens if that force is removed? If we're talking about two people swinging in a circle around each other, sort of half dancing, where they're going around and around, is there an acceleration? What provides the force to keep them going in a circle? And what happens when that force is removed? If I'm talking about an object like a satellite going around the Earth, it's going in a circle. It has an acceleration. What's the force? What provides the force that keeps that object going around in a circle? The second question has to do with the force due to gravity. We've talked about the force due to gravity and the acceleration due to gravity. We can write that as a sub gravity, or we can just write it as g. On the Earth, that's 10 meters per second squared. We know from class that we can put those together and write the idea, since F equals ma, that F equals also mg. My question is, what happens if you get far from the Earth? Does that acceleration, and therefore that force, still stay constant? Or does it get weaker? Second of all, what happens if I change the mass of the object? I make an asteroid, or I make it Jupiter, or I make it a black hole. If I change the mass of the object, does the force change? And what if I change the mass of the other object? Let's say somebody like me, who looks like that, somebody like my wife, who looks like that. Are the forces for those going to be different? And what does all of that say? What does that imply about the gravitational force in general when we get far away from an object? We'll talk about that and more when we get together on Friday. See you then.